So once we have discussed this, let us solve one problem. Okay. So the question is find. Okay. If you want, I can write down the exact question if you want. Okay. So the question says use center different approximation to estimate first and second derivative y is equal to e raised to x is equal to 2 for h is equal to 0.1. Okay, the step size and employ both OH square and OH raised to 4 formulas. Okay, so this is the problem that we are going to solve. So what does the problem says? Y function of x is nothing but e raised to x, and we have to find out the derivative. It is y dash at 2 and y double dash at 2, that is the second derivative, and the first derivative that is equal to 2. They have also given the value of step size, that is 0.1. Okay, so let us solve this. So you have to solve it using centered difference approximation and employ both x square, h square and h raised to 4. Okay, truncation error. So you have to use centered difference scheme of second order and fourth order and second order. So if you want to do that, let us write down the formula. Let us do the first derivative first. So what is the formula for central difference scheme for first derivative with first order approximation? This is the formula. Okay, and this is for square. And if you want to write down the first derivative, formula for first derivative with the fourth order approximation, centered difference scheme. Divided by 12h. Okay, so if you want to find out the first derivative, so you can see here that you have to find out the value of yi plus 1, yi minus 1, yi plus 2, yi plus 1, yi minus 1, yi minus 2. If you find out these values and if you substitute those values in this equation, you will find out the first derivative at that particular point. Now to do that, let us draw a table. Okay, so when I say xi, what I'm actually talking about is x. Okay, and that is nothing but 2. So when I write xi minus 1, so what I'm saying is x minus h. So what is the value of h? H is 0.1. So 2 minus 0.1 comes out to be 1.1. So till where we are going to go? Till what value you are going to calculate? If you see, we need x plus 2 and I plus 2 and I minus 2. So we'll go till I minus 2. So that is going to be h minus 2h. Okay, and if you do that, 2 times of h, or simply if you don't want to write down 2h, you can just subtract 0.1 from the previous value, that is h. So this is going to be 1.8, and similarly this is going to be I plus 1, this is going to be x plus h, that is going to be 2.1, xi plus 2 is going to be 2.2. Okay, so what we need is yi plus 2. So when you say yi plus 2, what you are saying is y at xi plus 2, and that is nothing but y function of xi plus 2. Okay, and what is xi plus 2? That is 1.8. So what you are going to do is you are going to substitute 1.8 in this function. And what is the function? E raised to x. So if you do that, the value comes out to be 6.049647. So I'm using 7 significant digits, okay, to avoid the round of errors. Similarly, if you want to find out, I'm sorry, this should be minus, I think. So again, this is going to be yi minus 1. So that is going to be f xi minus 1. And when you substitute the value of 1.9, that is f xi minus 1 in the function here, okay, you'll get the value, and the value comes out to be 6.68589. Similarly, yi is 7.389056, yi plus 1 8.166169, and yi plus 2 9.025013. So once you substitute the value of y minus 1, or y minus 2, y minus 1, yi plus 1, yi plus 2, here, and here, and also the value of h and h, you'll find out the value of the first order derivative that you are getting is 7.401395. Okay, this is using the first order approximation, central difference. This is going to be 7.389055. Okay, so when you substitute these in these formulas, so this is what you're getting for this, this is what you're getting for this. Similarly, what you can do is you can write down the formula for second order derivative. So what is the formula of second order derivative? So this is h square, centered skew. This is of order h raised to 4. So the good thing is for second derivatives we already have calculated the required values of yi minus 1, yi plus 1, yi minus 2, yi plus 2. So we just have to substitute the values. So once you substitute the values, you'll find out the value of the second order derivative is and this is. Okay. So you might be thinking why it is same, but if you see the function is e raised to x. So the first derivative of e raised to x is e raised to x. Second derivative is also e raised to x. So the function here that I took was very simple. And we also know the true value. So when you solve this analytically and when you find out the true value, it comes out to be 7.389056, okay, which is very close to this, and this. So this was your numerical differentiation.